right, so here we are, everybody, for Unit 16. We're going to be talking about web servers and applications this week, which is a huge topic. And this is one of the things that got shifted around a little bit from last year to this year. We went from sort of like 2 weeks of this to 1 week of this, so it's a little shorter, a little bit more compacted, because it's an amazing, huge field topic, but it's so big and so scary for a lot of people that it's not one that that we want to just like make sure that we touch on. There's tons and tons of depth. You can totally have an entire career doing this, right, Vincent?
Yes.
Yes, absolutely. Web servers and applications, you can have a full career, many different types of full career to do this. But the main thing that we're going to go over is sort of like the nuts and bolts of how, and then we'll sort of look at it from the maker perspective. We're lucky that with us today is Vincent, and James is here too. Vincent's a pro in this field though, so he's gonna feel free to just chime in with whatever pops into his head. So there's lots of interesting things for us to look at as we move forward, but there's a whole bunch of slides. I think that there's like 50 slides in this round, because I just basically took the 2 weeks and mushed them together. And so we'll go fast, we'll go slow. If anybody has any questions, this is a great one to ask questions in, because I might have answers. Vincent definitely will have answers, probably, and hopefully. And between the group of us, we'll feel a lot smarter at the end on things that really, I think fundamentally, everybody should have some understanding of how these pieces work, because it's how the internet works. So, but the very first topic on the overview bullet list is how the internet works. And that is a big claim. So it's a series of tubes. Yeah, it's just little tubes with little tiny lemmings carrying messages. That's how it works. So we're going to add in context from that. Then we're going to talk about your computer as a server, Linux in general, Raspberry Pi and server farms, cloud computers, platform as a service, interfacing, so GUIs and how you like interact with a computer, the terminal, basic Linux commands, and then your first actions. If we make it through this set of slides, we're good. This is 1 week's worth of slides. Although I will say, because this is basically 2 weeks sort of mashed together in here, this is based on feedback from last year, there's a whole nother overview coming later on.
Each bullet point is a rabbit hole.
Yeah, 100%. Each one of those things. So
don't feel like you have to know everything about each point.
Yeah, honestly, there's no way you can know anything, all of it, about any one of these bullet points. So first up, we're going to focus on the nouns, like what is the internet? What are the things of it first? Then we're going to talk about the verbs that come next. So the first like half of this would just be the stuff of the internet. The second half is like, how do you do internet? So first up, how the internet works. This is a big ask for the world. Basically, I've tried to color code this with a whole collection of ridiculous photos. Let's say you just want to visit a web page. You, on this yellow computer, ask a browser for a page via URL. So you send a URL out into the world. It hits a DNS server right here that just takes the skittles.com, and it knows, oh, skittles.com, that's this IP address. And so it reroutes you to another server that like gets you set up to be connected to to send your request to the right server, the one that you want to get to. That server could do a whole bunch of things, like it might need to go get information about Skittles from another server across the internet. It might be building things internally. That server that's circled in orange is the one that's providing you the website, but it might be going to other web pages and other places to get content it needs to build that website. So it'll do that, and then it's going to send that information back to you through this other pink arrow, and at your computer, it'll all just show up. Then those files that are sent back from that server are downloaded on your computer. They're opened by your browser, and your browser opens those files and loads them and shows you a picture. All of that happens inside of, here's the DNS lookup part. Here's the request response. All of this happens in 150 milliseconds. Like, it is an insane amount of information being transferred back and forth. The number of requests can be really gigantic. There's tons and tons of different features to think about with this, but it all happens in milliseconds. Like if it takes 500 milliseconds to load your website, you've got a bad score.
Is
there's
that even with like a fairly rudimentary internet connection, like it still can go pretty fast?
it's very different than like when we were kids.
Yeah.
And like I remember being yelled at for being on the internet too long because it was tying up the phone line. In that case, like it blows my high schoolers' minds that there was a moment before YouTube.
Right.
But like now, essentially, at-home internet is 100 gigabytes per second. 100 gig connection is $40, $50.
Yeah.
And at that speed, like your link is never the bottleneck.
Got it.
It's the processing on the servers, how many different ones do they need to connect to.
Got it. Okay.
It's never ever you.
Yeah.
You can stream 4K video just fine at like 6 or 8 megabytes per second.
Okay.
And so, or gigabytes per, like megabits per second, all that was megabits per second. So like it's transitioned now to, it's more what do you want to do and how complicated are the requests.
Got it.
So there's a lot of interesting things going on here, but basically you should really think of it like a web. When they call it the World Wide Web, that's an apt definition. The big thing is that basically you're trying to download files from other computers, and then your browser opens and manages those files. You can use JavaScript to keep connection alive if you want more of a connection to that server, or the most common way is like you get information from a website and then that's it. That's the like basic version. And all of it happens really fast. So the internet is essentially just a collection of servers with public or like limited access available. So it's just a bunch of computers that sit in someone's office building and they're ready to send you a file whenever you ask for it. So they're sort of like, they're just ready to send you information whenever you make a request. It's really just a whole collection of servers. Servers can be anything from the little Raspberry Pi that's like literally the size of my thumb that's sitting on the table in front of Vincent, all the way to like, I used to live next door to Progressive Insurance, and they have 2 server farms in the country, and they like run liquid cooling through the floor. They refrigerate the room so that it doesn't get too hot. And they have incredible computing power that their servers like have to exist in duplicate on 2 different halves of the nation's power grid. Like it can go anywhere from like a weird little computer that you can fit in your pocket all the way up to crazy big time. And so the internet is really like what we think of now as the internet is just an emergent property of all of these, you're good, of all of these computers all being connected together. And so just by having access to all of these computers, you get the benefits of the internet. There's lots and lots of websites that you visit that are built off of 5 or 6 different servers all at once. So really the amalgam of what we have is an emergent property, just like we think that, you know, other weird things are emergent properties, like states of matter or consciousness or whatever. There's a bunch of weird things that are emergent properties, and the internet is one of them. So what's at the core of this? HTTP requests, hypertext transfer protocol requests. This is how most things go back and forth on the internet, or at least it has been for a long time. And so you can read all about it if you want to go to the MDN web docs. You can read, here is all of the like authoritative content about what the internet is, how it works. You can read all sorts of stuff. This is hosted by Mozilla for developers, so you can really go deep into the weeds if you want to. But this is the basic core of what happens. Essentially, there's multiple different types of requests that you can make to a server. So if your computer is talking to a server computer, the most common thing that you'll do is a GET request. You'll download a file, like download skittles.com if you want to go to a website. That's the most common thing that you'll do. But if you want to put something down, put up a weird cat meme onto Twitter, you'll make a post request where you're going to push some information to the server. And that's essentially the 2 most common. There's a ton of other options for how you can communicate back and forth with servers, but GET requests are when you download, and post requests are when you upload, and then there's like 5 more.
There's
So
a lot more, but they're not really used.
yeah, there's only like 7 that are
There's
even,
some joke ones too.
yeah, I'm sure that there are, but these are the 2 biggies by and large. In general, when you make that request, there's a bunch of information more than you get to see in your browser, but that other information is usually like information about what just got sent. So it's like the header that describes what's being transferred. And this is where you might get a 404 error. There's different errors happen when these requests go bad. So a 404 error is a user error. There's 500 errors when the server error happens. There's 200 messages. 200 messages are when everything's working. But in general, if you were to open up a website in Chrome, you can, let's see, this is all from when I was building. I'm going to pop over to another web page. It wasn't that long ago. I have a magic mirror in my living room, and hopefully one day soon, since we're all getting close to being able to be around each other without masks, we'll host a barbot party. And when you come over for the barbot, you'll see that I have this magic mirror in my living room that's got the tides that are live posted. But basically, it goes and pulls information from the web, from the National Oceanic and Atmospheric Administration, and it live charts what the tides are for today. Wrote this in JavaScript, added it to Magic Mirror. It's lots of fun. You can download and install this if you want, but this comes out of Magic Mirrors, which are like mirrors that you put up on the wall, and then they've got a screen behind them, so you can show off all sorts of weird things through your mirror. Basically, I made my own little app to fit with. I'm really enjoying living close to where the tides happen, so I've got that all queued up. And so anyways, here's that website. This is the actual content that would turn into something that's displayed on page. And then over here, you get a bunch of other information that's like where it comes from, how did you get it, when did it get sent, when does it expire, some of those different like metadata that you'd expect, all the stuff that like when you take a photo on your iPhone, there's a whole list of information that you don't ever care about. The header is that information, but for a website that's being sent back and forth. So it's good to know that that exists, and it's not just the information that you get. There's definitely more header information that's there. This can lead to a lot of interesting details. But basically, you can send information back and forth from a server. And inside of any of your browsers, there's some sort of an inspector that will let you take a look at what all this is, how do you get there, and you can really go deep into the weeds for what all this is. But some context. You can also use your computer as a server. And so I've got that set up right now over here. One of the things that we have done in the past is we've had, let me do this. Don't show again. I'm going to close this port. One of the things that we've done in the past is we've hosted web pages for foundations. And so this was Ted's awesome Foundations of Fabrication website, right? And so in here, this is an example of a quick website that I had written for a previous year of Foundations of Fabrication. It's 46 lines of code for this page. That's it, not counting all the stuff that I'm getting for free from Google or from other, like I've got styles with CSS written in here. So there's a little bit more code that exists over here. But basically, I'm going to take this page and I can use my computer as a server. So I can click on this and make my computer a server. And now anybody can go to my laptop's IP address, port 5500, and it will show you this page if you're on MakeHaven's Wi-Fi. I don't know my laptop's IP address at the moment, but it's right now, my laptop is acting as a server for this website. And it's able to link between pages. I can like click around and look at things. And so I can do all sorts of interesting stuff. There's JR. And so this is just a file that's being sent from my laptop, kind of oddly, back to my laptop so that it's able to see that. But basically, let's head back over to the slides. And here, you're able to use a live server extension and some code that you've written to really quickly get a website up and hosted from your own computer. So if you're writing a website, instead of having to go through all the mechanics of like hosting it somewhere else and doing other things, what people will often do is they'll use live server right out of VS Code so that you can host a website from your laptop. It's super easy to do. It's an extension that you can just install, and then you can play around with hosting web pages. However, most of the time people don't want to host it from their own laptop. Like if I had a small business and I wrote the website on my computer, I would not want to have to leave my computer turned on all the time because that's eating up power. My computer I probably want to do other stuff with it. So I can instead use different computers that live in other places. But one of the things that has been a real rub on, that's made me upset for a while is that when you have to buy a new computer, you have to pay for an operating system. doesn't quite feel true anymore. Feels like you get it for free with the computer. But Windows and Mac, you still sort of have to pay for when you get them if you have a computer that it needs to be installed on. But Linux is the free option. So you can do different things. It's also more like customizable. But basically, Linux is the system that most servers are running on. Like 85% of the internet, and that's a rough, almost out of thin air number, 85% of the internet is run on Linux. Probably higher.
Yeah,
Probably.
roughly that area.
Yeah, 85 or up a little is basically all the computers that are running and serving you files, they're all Linux machines. And so there's a bunch of different flavors of Linux, but one key thing is that it's free and open source, which makes it a really nice, appealing venue for developers because you can fiddle with it, you can tweak it to fit your needs, and it's free. So like you don't have to pay any maintenance fees to get it, you don't have to buy it. And so that totally works. Mac and Linux are really close cousins. So if you have a Mac, you're probably pretty good at Linux already, especially if you ever use the terminal in your Mac. And I don't know many Mac users that do, but there's a handful that definitely do it a lot. And then Windows has started to embrace Linux. Really in Windows 11, the Windows subsystem for Linux has gotten quite good. And I can use Linux-based commands in a Windows computer, and that wasn't true for a long time. It's even like running Windows or Linux in the Windows. So there's some cool stuff that you can do. But within Linux, there's tons and tons of distributions. Vincent, you run Linux on your computer normally, right?
Yeah.
Yeah. So you can totally get used to it. It can be your absolutely daily driver computer. There's no reason why you have to be a Windows or a PC. There are other options, but there's a ton of different ways. Tux, the mascot, is Tux the Linux penguin, is pretty universal across Linux. Ubuntu is the most common, like full force, like I'm going to use this as my daily computer. Most people will just load Ubuntu.
It's pretty much the Windows of Linux.
It's the Windows of Linux. Then there's like XFCE desktop and different flavors of Linux that you can have. But basically, we're just looking at different versions of almost the same thing, making people who get real into the tweaking it to fit their needs, and then communities that maintain those subgroups. Sort of like there's a pretty good reason to think of it as like denominations within a church, or with like different types of church. People get in, they feel strongly, and then they go for it. So Linux, the one thing about it though is that Mac and Windows are pretty identifiable. Like you can tell if someone opens their computer, or maybe even before they open their computer, what's going on inside. But Linux does not have any of that. It does a really good job of turning into whatever somebody wants it to be. Like this is the Ubuntu desktop from some version ago. This is the Raspberry Pi desktop. You can have it run completely headless without a graphic interface, so no fun pictures, just words. And Android is totally just Linux. So all of that these are all different things that you can take a look at. And because there's no commonality, what very heavy Linux users will start to get used to is not relying on their graphical interface. They'll instead start to rely more on the terminal to run commands and run programs and do different things. I've even known some people that like will try their very best to compute without a mouse. And so, which is really like, I suppose it's an achievement. There's also people who have keyboards without any letters on them. I don't know if I understand either of those scenarios.
When I was in high school, a freshman in high school, building a computer for the first time and was still waiting for the mouse to come in the mail, I was like, I got to make this keyboard work.
Yeah, I've done it in a pinch for sure. But like, I had a roommate who fully believed that if you couldn't run the computer without a mouse, you were doing it wrong. And I don't know, that just feels extreme to me. Whatever, fine. So in here, the big thing is that across all Linux, no matter what it looks like, no matter how you interface with it, whether it's touch or a mouse or whatever, the terminal is the common link. And if you can get access to the terminal, you can run commands that should be universal across versions. Because even though the buttons might look different, and this is a pain point for people in Windows, when you get a new version, all the icons change. In the terminal, it's going to have the same name. So you're not going to have a different name for the same program. You should get a pretty consistent experience across there. And it's why most tutorials are given in the terminal, so they don't have to guess what version you have and what it looks like. A big and common player in this game for somebody in a makerspace is going to be Raspberry Pi. Raspberry Pi is that little wallet-sized computer that's down in the bottom right. They're $40 or less, so that's a nice price point. They're super easy to reset. You basically can't break them. And even if you totally destroy the operating system by screwing things up, it's very easy to just flash a new operating system onto the SD card and load it back in. It's also got these pins up here on the right where you can use GPIO like Arduino can. Different voltage, different power requirements, but basically they give you access to have Arduino control, but with the full power of the internet at your disposal. And so you can do websites and things off of them, and there's tons of tutorials about it. So there's lots of opportunity. There's even Pi Academy where you can get trained, officially trained by the Raspberry Pi Foundation. It's generally geared towards teachers, and I've done it. It's fun, but it's its own whole thing. Raspberry Pi server farms, Raspberry Pis and server farms. You can imagine having like 4 or 5 of them. You call that sort of like a printer farm. If you have 4 or 5 3D printers, if you have 4 or 5 Raspberry Pis, you've got a server farm. And then here's what a big server farm could look like. These like blue things are to pass cold air through all those computers. You're trying to do this. You're basically trying to build up your ability to host a website or a service. A person who's got a small business that doesn't get a lot of traffic on the web, you might be able to host a website off of just a handful of Raspberry Pis. But if you are running Skittles.com, where millions of people come to the website to learn about Skittles, then you're really going to need to have a lot more computer. And so you can do lots of different things to try and get that, but you can go anywhere from tiny little computers all the way to huge farms to make this happen. So in general, most of the time, businesses will very frequently nowadays choose to not manage the hardware of their websites themselves, because you have to physically build something, you have to bring in air conditioning, you need engineers just to maintain that room to like keep it stable and working. And it's much more efficient for most companies to instead just do cloud computing, where they pay another company, most likely Amazon, to host their website for them. So they're not in charge of the physical object of the computer that's serving the websites. They just push code to that computer, and then that computer is the one that actually talks to people that want to visit. And so this is in general cloud computing. Here's several options for how you might do that. Amazon Web Services is the biggest one among them, but there's Microsoft Azure, Google Cloud. You can host websites right off of GitHub if you want. Cloudflare, Heroku is one where it's interesting.
Are you talking about VPSs anytime soon?
Probably not, because I don't know what that acronym is.
Virtual private server.
Oh, yeah.
So it's like having the Raspberry Pi, but someone's hosting the hardware for you.
Yes.
So like AWS's options lean more towards the VPS type options.
Sure.
Heroku is more on the extreme of like the platform as a service option.
Right. And so Amazon is setting up
everything.
Right. And so Amazon offers all of it. You're right. And so just to try and unpack that or say it again, Amazon it's more or less you're pretending that you have the computer with you, but instead Amazon is the one physically managing the hardware and hosting it.
Pretty much, yeah.
Yeah. And then you can take that computer and open a port to the internet if you want, but basically it's a remote computer that your company has access to.
More or less.
Yeah, more or less. Versus Heroku, where like
it's plug and play. You just hand them the app and you tell them where to start running your app.
Right. And that's I've done Heroku multiple times. And it's nice and easy. If you can code it and run it from live server, you can code it and run it from Heroku. And so it works really nicely. Whereas there's definitely, it seems like a steeper learning curve on the Amazon Web Services, sort of. But in here, all of this I would throw into the cloud computing bucket. And so VPS or PaaS, there's a ton of acronyms that go in this for like how you want to do that, but just generally thinking about cloud computing as a group, these are sort of the places where I start to think about it. In general, if we're going to talk about all this networking stuff, one of the things that's important for someone who's getting in is to think a little bit about safety in networking. One of the main reasons why I would encourage somebody not to host a website from their own house, even though you could do it for free or just like the price of the electric, which in Connecticut is totally a price to consider. Feels like it's a lot less in Ohio. But you want to think about the safety of having a bunch of people come to your home, like to your home internet and asking you for a website, right? That opens up a hole in your security that lets people in. And so basically you could do that with port forwarding. And if you've ever fiddled around with your server, port forwarding is an option where you can let people in or you can push things out. But you got to be real careful not to do that in a way that provides access to everything in your house. And essentially just don't do it. Like the short version is you got to really know what you're up to if you want to do that. If you want a hobby website to be used by the internet, you can use a cloud service. It's totally safe. It keeps your personal things from being accessible if it's all existed in the cloud. You can local host websites, so only people like in your local network can get to it. That's how I host the website for my robot bartender, is a local hosted website, and it's not accessible to the broader internet. But basically, I would say don't open port forwarding unless you already know what that is and you're very sure you want to do it. Does that feel right? Yeah.
And even then, consider using a VPN.
Yeah.
If you can go through the tutorials to set one up that way.
Yeah.
So you have to log in to be able to get to it.
Yeah. And basically, if you can avoid port forwarding, you should avoid port forwarding. So it's just like a little buzzword that doesn't get enough danger flags on your like router at home but you should still keep an eye out and not do this. But it's kind of hard to turn on by accident. So that's good. So how do you interface with a server? There's a bunch of ways that you can. And so the most common one that I've met people who are trying to talk to a remote computer is they use Citrix. Like my wife, Carolyn, uses Citrix to log into a hospital system from home. Her mother does the same thing. She works at a lab for a hospital. There's lots of different people that use. I worked at a school that had Citrix access to my computer at school, which is interesting. But it's a system that you install locally that connects as a VNC connection, so you can like interact with the interface on the computer over the network. It's really interesting. It's really slow usually for Citrix specifically because it's got all the security things wrapped up that it needs to do. But it totally lets you interact with a computer that's not yours over a network connection. And so that's a critical thing.
So we're not talking like Cisco VPN, where like I'm from my house logging into the server at my job. We're talking about like from my computer, I'm logging into your computer at MakeHaven and manipulating your computer.
That's probably the same deal. Like the Cisco VPN is probably the same sort of service as Citrix.
Okay.
Where like you can log into that computer that's hosted at work from your computer.
Got it.
Right?
Yeah. Or like you like bring my work computer home and just get a secure access to their
network.
Yeah, and their network.
Oh yeah, that's another interesting. So like Citrix, you're accessing a full separate computer that's there.
Okay.
Yeah.
Okay.
But what you're talking about is like a secure network connection.
Yeah. So it would be like if I left my work computer at work and I use my laptop to just use my work computer at work from home.
Yeah, pretty much.
Okay.
Which is like
pretty cool.
There's a ton of cool options within that space, and different companies will choose like what's the best one for them. Hospitals really like Citrix because it's secure end to end, and like there's different levels of security.
The computer stays there.
Yeah, and the computer is there. So there's a bunch of reasons to do this. You can totally just get VNC Viewer. Like you can log into a Raspberry Pi with VNC Viewer, have it connected to no monitor at all, and then basically look at its monitor through your computer. So there's all sorts of different ways that you can make this work. But this is with the remote thing, and you still have all the like user interface GUI stuff.
With VNC, a lot of the setup that you need to do does involve the port forwarding.
Yeah.
Because you need some way to talk to the computer. Citrix and other services get around not having the ability to port forward by talking to their servers to find out where your IP address is and to try to mediate the process of talking to your computer.
Right. They can probably encrypt what you're sending back and forth, or like filter out like, oh, this is malicious in some way. They probably have something in their secret sauce as a business that's letting them do that.
Possibly.
Yeah, I would guess.
I know for TeamViewer that they'll say like free for personal use only if you have to pay for commercial.
Yeah.
And they'll flag to you sometimes saying, hey, we think you're using it for commercial purposes. So there's some sort of monitoring.
Yeah, no, that's interesting. So all of that exists as a service. Most of the time, a hobby user won't do any of this, but it's good to like have some context for how it fits in with what you might do for work, I think. So One of the things though is that the terminal is usually much faster than any of those systems, and it's way closer to what the machine's like internally thinking. If you want to try and imagine it that way, basically lots of software gets written as just like code, and then a GUI is tacked on. And so essentially the terminal lets you sit closer to where the computer is doing its thinking. And so it's really also much older is one of the things. Like the first computers, the GUI came much later. It was a much later invention than the computer itself. At first, programs ran like this, where they just looked like text on a screen. And then eventually we had the Commodore 64. And before that, I think it was the Mac was one of the, or there was maybe Xerox had some of the first GUI things.
The X window system.
The X window system. Yep. It was one of those. I knew it's somewhere in the back of my mind, the computer science history. But X window, do you know who was it? Xerox?
I believe so. I don't remember.
Yeah.
They were involved.
Yeah, I think it was Xerox, and then Mac stole it. And then like that's the big Silicon Valley drama you can watch all about. But basically, this is much closer to what's happening inside of a computer, and all of the visual layers added on top just to make users happy and to make it feel friendlier and more useful, which is totally the way that it works. Microsoft DOS might be an old familiar memory if you ever played around in that. But really, since a computer is closer to dealing with the terminal internally, and then all the pictures are just added on top for humans, it's why developers, many people might prefer to go straight to the terminal to do stuff. And if you're going to make a network connection, it's a lot less data to send back and forth just text versus like loading the photos of your screen and then you're dragging icons. Like that's a lot more information that you have to actually send. So the SSH or a secure shell is a cryptographic network protocol to let you operate a computer remotely. And so you can enable it on a Raspberry Pi. You can run a Raspberry Pi totally headless, which is what we're doing here. And so in this, you have remote access. You can set up all the instructions, or set it all up right here if you have a Raspberry Pi. And so you're able to go at it that way. But essentially, you can get total interaction with your computer this way, as long as you're willing to give up all of the graphic stuff. So basically, for a Raspberry Pi, all you need to do to enable it is you can follow these instructions, which are right here on screen. You can sudo raspi config, interfacing options, SSH, click yes, okay, finish. If you have a monitor, you can also set it up before you even do that. You just put in a little file that's called SSH with no file extension, and it'll turn it on when it loads the Pi for the first time. So that it's a really already done this. And so there's a little Raspberry Pi that's over here, and I can, well, it's, I'm gonna grab it and hold it up. It's this little tiny thing that's still going to be very small on Zoom, but this tiny little computer that has an ability to interface with it is all set up for SSH. And so you can interact it through the terminal really nicely. Once you're doing that, there's a whole host of commands that you might want to use to actually do that interacting. And so the big one within, if you're brand new to Linux, the big one that you're going to use a lot is sudo, which is super user do, sort of. It's the command that gives you access to read, write, and run things. In order to be more safe and secure, the default user Pi does not have a lot of permission. And so you can do super user do if you wanted to override your like permission access. On Windows, it's run as administrator. On Mac, they probably have the same thing, where you have to type in a passcode to get things to run.
On Windows, they typically don't ask for the password.
Yeah, they usually don't. You can
You
configure.
already have admin access.
Yeah, usually. Yeah, that's right. You usually do. But other commands, these are just some of the most popular Linux commands. There's ls, which I like to think of as list stuff. It lists all the things in a directory. CD is change directory or change folders. And so you change directory, and that blank is where you want to go to the place. Or if you do 2 dots, CD ... it goes up a folder, or you can go down a folder. If you ls, you'll get all the folders listed. And then you can CD and go up a command. Let's see, I should also, while we're doing this, bring up Windows PowerShell and actually do this in front of you for some of these things.
You have WSL installed?
I don't know. I don't want to live demo that. but I probably should. Oh, I don't know, actually, on this laptop. I
You
do.
type in WSL,
Yeah.
then it'll load your default if you have it installed.
Arguments.
So you don't have one.
Yeah, I don't have it. Okay, all right. So we're just gonna do SSH pi at 192.168.1.144. Yeah, I think that's what it is on that little screen.
It's on a different IP address. It's like 10.0.0.14.
Oh, is it?
It doesn't work unless you're on the 5 gigahertz router. For some reason.
Great.
That's why I whipped out the keyboard earlier, because I was like, is it not connected?
Okay, all right. So it's having a hard time. We're having a moment with this that's on screen right now. Yeah, we're gonna make sure that this is sorted before we walk away today. But I got it working yesterday. In any case, you'll be able to issue a bunch of commands. Nano is a little text editor that lets you do some text commanding. MKDR is make directory. You make a new folder with whatever name comes next. Python lets you run a Python script. ifconfig will tell you the device's IP address. Help is pretty common for lots of programs. You can do -- help, and usually it'll list out all the stuff like you saw happen to me with when we typed in WSL for Windows Subsystem for Linux. That I need to get back up and running, or I need to get up and running on this laptop. But in here, I can do this and install. Oh, I could just install it now. But then there's reboot or halt. Halt is shut down. Reboot restarts the machine, and Control-C will usually stop most programs once you're in the terminal. So those are the most common ones. There's a
Also
full
man pages.
and what?
Man pages.
Man pages.
Or the manual pages.
Oh yeah, that's a good one.
So if you type in man and then the name of the program, then it'll give you a list of manuals.
Oh, cool. That's
Most-
good.
Assuming the application has a manual for it, but most of them do. So you just type in man, name of the program, and it will tell you how to use it.
There you go. So there's those options. Here's a whole bunch more if you want to learn all kinds of different commands. These are common commands for Linux. And so Vincent's totally got much deeper well than I do on all of these details. There are things that usually I know I want to do, and then I go find the command to make it happen. Or if you're getting instructions for how to do something, like you're just following instructions from the internet, they'll usually say these are the commands to type. You just need to type them in the right way.
So since the Raspberry Pi is just a tiny little Linux computer, most of the commands that work for Raspberry Pi will work for any Linux computer.
Right.
So this document is not just Raspberry Pi commands, it's also Linux commands.
It's also the one that is not RaspberryConfig is a Raspberry Pi specific one.
Okay.
But beyond that,
Most of them.
almost all of them work.
Got it.
So it's really broadly useful. And so if you're learning how to use a Raspberry Pi, you're totally learning.
You're
how to
learning
use-
how to use Linux.
Yeah. Yep. Or home.pi or home/pi/office. Pi is the user. So if you made a James account, it would be home/James/office.
Got it.
So all of those different things are little details to think about, but these are the commands that let you do some of that. Okay, so there's the Raspberry Pi that's hidden in MakeHaven, and it's hidden on the table in the room with us. So it's not very hidden. And so what we're going to try and do is play a game over the course of the week where you're going to get there. And so we're going to make sure that it's set up the right way before I leave tonight. But the main thing that we want you to do this week as just sort of the assignment for the week is to SSH your way into the Raspberry Pi using your secure shell. And every computer's got access to it. Edit the file washere.txt to include your name at the end, and then run the command hideandseek.py, which is going to be Python hideandseek.py to start an LED blinking. So once you get it up and running, you should be able to just do Python hideandseek.py and it will start blinking. Which feels weird, but the practical upshot of which is that it starts blinking and it will be in MakeHaven somewhere. So it's like the nerdiest game of hide and seek this week, where you'll be able to get into the computer, send it a command to start blinking, and then go wander around the space looking for a little blinking blue LED. It's like a fun, weird hide and seek that's neat to do. What I found is that many people have never logged into a computer remotely this way. And so it lets you get in and play around. This is something, though, that can definitely be a lot. And so let's see if we go to YouTube, it's listed, or I put into Slack. Go to my channel. Let's see, I've not got a whole lot of interesting things going on here, but inside 12 whole subscribers. This is last year's set of instructions, and I made a new one. So there's going to be a new update for what's going on, but this is basically how you would have done it last year. I have it unlisted, so you can go back to Slack and check and see how to do this. The name of the files were slightly different last year, but basically it's the same deal. The real win that I got is it's a smaller Raspberry Pi. The battery pack is going to last a lot longer, and it's got a little OLED screen on it, so it's got more information for you when you get there. But there's a video that should guide you through how to do this, and you should not feel like you're out on your own. And so somebody who's brand new, this will totally be enough to keep you excited for what's going on this week. But there's tons of other options. If instead this is old news to you and you're very already used to this, you could totally just get a cheap Raspberry Pi and set up a server yourself. You could try and learn a new to you server skill, because there's always a million. Like one I'd like to learn is Dino for hosting websites instead of Node. I think that would be fun. There's a lot of different things that you might want to learn. And basically our only goal for anybody is to try and get a little bit more oriented this week with servers and how they work. There's a lot that you can do. Like once you start to get better and better at web servers, you've got more and more power and potential open to you from computers. Just because you're learning how to control and automate things, you're learning how to make the internet work to your advantage. There's lots and lots that you can try and learn. And it's a very, very deep well of information. So you can learn all sorts of things.
So I have a quick question.
Sure, yeah.
So just to clarify, we're
Yep.
going to be using our own computer or potentially phone
Yeah,
to access this computer over the MakeHaven Wi-Fi network.
yes,
Yes, you have to be here
So we're going to SSH into this computer
yes.
and then using this our terminal to access this computer's terminal.
Yes.
We're going to edit text and set the light blinking.
Yeah, totally. And I like on my phone, I have an app that lets me access a mobile SSH.
Got it.
So like on my phone, I can go in directly to that terminal
Got it.
thing. And here Vincent got it to blink. So totally, and I'm gonna swap, let me stop sharing and then change over to the other camera so that you all can see this. But there's these guys, and Vincent has got the thing blinking. He's able to get to it and control it over the network, where he can send a command and make it blink, which is lots of fun. So his computer is controlling what's happening to this little one. And that's essentially the goal for the week, is to try and use your computer to control that computer to get to blink and then go find it.
Pretty cool.
It's kind of fun that like most people have not interacted with a computer that way before. Oh, am I sharing the wrong screen? Stop the share. Share my second screen. That's the one. Okay. So that's really the thing that we want people to do. And it's definitely something I'd be happy to sit down and like walk through it with you without a problem. Thursday and Sunday, I'll be around just fine. But we've got more information. There's tons more to know about the internet. We can try and whiz through some things really quickly, but I just want to say that that's the core of what we wanted to do for this week. Also, like other important, before I hop into more internet that we can like click through really fast to see what's there. The other things that are worth thinking about is next week is going to be going to be an integration week. So it'll be less of me talking and more just time for you to do things, where we have a fun, like work on a project of your own design. It could be integrating the things that we've done recently, which has been a lot of electronics. It can also have nothing to do with that. It can just be integrating different skills. And so you can really go any way you want with that, but it'd be fun to have another moment to try and integrate these skills together. There's lots of good examples of integrating. Like you might have seen the piece of furniture that I've been building that brings together CNC and woodworking and epoxy. There's things like that. So just thinking about what you might want to do for an integrated project over this week and next week would be good. Because the server thing, like ultimately it's 15 minutes and you're done. It's not like it's super long, but you might need to wait until I am around, or maybe Vincent's around, and we can get you set up and running. So those are the things that we need to make sure that we get done this week, and then think ahead to what next week would be. But in general, one of the things that most makers are going to do with the Raspberry Pi is they're going to do physical computing. We've done it with Arduino, but you can also do it with Raspberry Pi. This is the like fun, weird projects where you can do a Raspberry Pi laser tripwire. You can make a poetry generator. You can do an image identifier. There's tons of weird things. And Raspberry Pi has really done a great job of making tutorials available. So you can go to projects.raspberrypi.org. And if you want to build all sorts of stuff, what would you like to make today? And so you can say, I want to build a robot. And here's a bunch of examples with instructions on how to build a robot. So if you want to build a line following robot, here's connection. Like these are instructions that what you will need, what you will learn, and additional information for educators. Like here's all sorts of things that you can do with pictures, instructions, the code that you need, little videos. If you want to build something fun and this is your integrated project, there's a lot of good reason to just follow one of these. Sure, their target age is maybe not full-grown adults. That's fine. Everybody learns somewhere and nobody starts off with a very complicated thing. So finding good tutorials is a gold mine, and you should totally do some of this if you're interested and want to try and get better over time. These are the line followers, by the way. And so it's just showing you how you'd hook these up, what connections you'd make with lots and lots of photos, which is usually where most people like to start. So there's tons of good examples. You can see here, it's like able to tell if it's over the line or not. That's really the core of how all this works. So there's tons of cool things to learn, and just following along, playing with projects. Here's your program. You can see the program's doing it, and they're like running you through how does your algorithm work, all of this stuff. There's tons of cool things to make happen. So basically, play around over the next, this week, we're just going to do the very start of SSH, but if you wanted to do something like this with a server, you totally could, or an Arduino project, or your integrated project could have nothing to do with anything electronics if you've decided you're going to swear it off for forever. And that's totally fine. But the big thing is that these exist and you have lots of options. So, sorry, thanks. You can make an automated garden. Sometimes it's useful to think about the same project, but taken from these two perspectives. An Arduino version of a home project, the Arduino is a little bit beefier, it's a little bit stronger, and its electrical connections are more robust. So the Arduino can probably directly drive the pump. A Raspberry Pi would probably need like a motor driver that's separate from the Raspberry Pi. So it's going to issue commands and then something else will do the work. An Arduino is going to be able to do some direct measuring. It's able to interact with some things in a little bit more real time, like a TV remote to control your garden, which feels weird, but you could totally do. But that requires very precise timing, and that's going to be harder for a Raspberry Pi. The Arduino is really good at some of the physicality of the electronics, but it's not so good at getting connected to the internet. And a Raspberry Pi is really good at internet, and it needs more like intermediaries to get motors and sensors and that sort of stuff to work from time to time.
Like putting an Arduino in front of it.
Yeah, sometimes the Raspberry Pi will run an Arduino and the Arduino does all the work. So those sorts of things can be really interesting, but there's strengths and weaknesses to each one of them. But basically the Raspberry Pi is internet strong and the Arduino is hardware strong.
So is the idea there making the Raspberry Pi inputs for the Arduino for?
It totally could be. Yeah, you
Would
could.
that be how you would do that?
Yeah, probably. Like if you wanted to have a garden that just like monitored how much light there was and how hot it was and then watered plants accordingly,
Yeah,
you could do that. And it could totally be Arduino. If you brought a Raspberry Pi in, you could also say like, okay, now go also check the internet and see if it's going to rain later today. And if it's going to anyways, then don't water the plants.
Got it.
So you can do those sorts of interesting integrations when you bring the internet capability of a Raspberry Pi into a project. And so there's other ways to do that also, but those are big ones.
You could say have that data collected or measured by the Arduino, sent to the Raspberry Pi, and the Raspberry Pi could send that off to like notify you or something.
Yep. Yeah, there's tons of different things that you get when you have the internet and Raspberry Pi connected into a project. Then we're ignoring completely the ESP category where they're like sort of blending between Arduino and Raspberry Pi, but there's tons of different ways you can go into these wormholes. In any case, there's lots of cool things that you can do with these, and the more you learn from both of them, the more adept you get at integrating and like using them together and making really cool like things that start to feel like they've gotten to be smart and come alive. So there's some cool depth that you can get into, but it takes a lot of work. Then the verbs. This is the second half that I said was here. We're going to click through this we're like 4 minutes from 8. So we're just going to try and click real quickly. In general, this is all about data, computation, the real world, and then apps. And so we're going to just try and buzz through these. This is, again, each one of these bullet points is a huge rabbit hole. So let's talk about data. First up, web servers in general. This is the software that you might run, the programs that would actually serve the websites. Flask is the one that I've used a lot. Django, these are both Python based. Node.js is super common right now for websites that are being built. Windows Server exists. People do use it. And Apache HTTP server has been the stalwart for a long, long time. Yeah.
It's not, there's some more nuance to that. Apache and Windows Server are a little more similar to each other.
Yeah.
Node a little bit more. But roughly, yeah.
There's lots.
Like you can host more than just apps using Windows Server and
Right.
Apache.
No, there's each one of these, it deserves its own entire like college course for sure.
It's the rabbit hole.
Yeah, it's the rabbit hole, definitely. So in general, basically a server app will, like Apache here, is going to listen to a port on a computer, and when it gets a message from the internet, it says, cool, I've got files for you, and it sends them out. That's what that program does. It's just constantly looking and listening to the internet and then ready to spit out information from the weird server computer at whatever strange IP address it is. So it'll send those files that your computer's asking for, and the server itself lives at the edge of the internet watching all the time for when messages come in. And so that's its own interesting program space. That's a server as a program, not a server as a physical object, which we've been talking about before, but a server as a program that your computer runs, like the live server that I pulled up for that website. There's also, and so here's a Flask server. Flask is one of those options. This is all the code that it takes to get a website to come out of Flask. So sometimes sometimes they're really simple. Like this is really cool. Here's the mega tutorial that I followed that really pointed in the direction for my robot bartender. And it's,
If you want to learn how to write an API or write like a web app, I would start there, like that specific tutorial.
yeah, it's a great tutorial. And so if you want to learn how to do any of it, it's because it walks you through the whole thing, start to finish. All the details are solved. It's fantastic. It's free online, but you can physically buy a book if you want. And as much as I bought the book, like it was just helpful to have it on hand. But then you have routes. You learn all about all this. If you really want to get better at it, there's tons of cool things. Node server is also really nice and easy. This is how much it takes to get a Node website up and running. So if you wanted to get just a simple Hello World website up, this is all it takes for code with the Node server program. This is all written in JavaScript like websites itself. This is your favorite, right, Vincent?
Node?
Node?
Not quite, but I do work with it regularly.
All right, well, that's fair. It's pretty common for websites nowadays because you can have somebody who's good at writing JavaScript for like in the client side computer and the server side computer, all one language. And that's got some real benefit.
This program is pretty much the exact same as the Flask one, but written in JavaScript.
Yep, totally. It's essentially the same deal. Then if you have websites, probably you want data to pass back and forth. And so you might do that with a database. These are all different versions of pretty similar databases, but basically there's a lot of different ways you can store data. We're not going to get into all of those, but basically a database is like a spreadsheet you can't look at. It's a spreadsheet inside of a computer, and you need to write all the scripts so that those spreadsheets can be handled instead of by an accountant who sits in the back office with no windows. This is handled by a computer that's got even less window access. So this is the way that you can store all your information. There's tons of different things that you can do with these. They're lots of fun to play around in. And if you really like nerding out in Excel, this is doing it at another level. If you're the kind of person that gets a little bit afraid when Excel opens on your computer, this is probably not going to be a fun space for you. Just want to give you fair warning.
But once you learn how to program, it's going to do everything you wished Excel could.
Yeah, that's true. Once you figure out how to, yeah, exactly. And I hope you heard Vincent say it, because it's totally true. So database tables in general, and I started to think about spreadsheets differently once I started to learn more about databases, but basically database tables, each row is its own whole separate thing. Like here's Respect Aretha Franklin. This is a database of like top hit songs. And so There's an ID entry, there's columns that describe just one type of thing. Each row is a separate thing. So this is Aretha's respect song. Here's like the Mamas and the Papas, Creek Alley, or On a Carousel by the Hollies, Don't You Care by the Buckinghams. Each one of these rows describes a different thing. Each column is a very predictable type of information, like weeks on the board or the peak ranking that it was. All of those different pieces of information. Each row is its own piece of info. It's probably how you formulate spreadsheets, but basically it's looking for that sort of a thing. And then there's these weird relational database things where people like to make these maps. And if you build your databases just right, you can get really interesting and complicated relationships that come flying out of there with tons of depth to go into. It's a really deep rabbit hole, but these work really fast and they work really well to connect the dots between information. So a normal way that you might get access, if you don't want to build your own database, you might want to use someone else's. And so you can totally do that with an API, an application programming interface, where you can have your computer go ask the internet a question and it'll respond in a computer-friendly way. Like, for example, the web page that I pulled up that was for the NOAA tides, this one. In here, this is going to the National Oceanic and Atmospheric Administration website. It's pulling information from them and it's spitting it out this way. And so it's going to get information in a different format that's going to be pretty useful. Let's see if I go to it's this one, and the website that I'm trying to get is almost this. We'll do begin date. I don't know if I have any of the example ones in there, but if I go into here, paste that in, and you can see it's sending back just like text, right? And this is not a full request. It's not all the information, but basically you can have your computer go to another server on the internet and spit back something that's machine readable. And that's the magic sauce of an API, that you can go and do that.
He just made a GET request.
Yeah, I just made a GET request to another computer. And so I went to the National Weather Service, or NOAA, I think, NOAA, and got information from them. But you can also go to Skyscanner to look at flights. You can go to CocktailDB for a drink database, or IMDb is the Internet Movie Database, where you can pay a monthly service and get information from their database. There's usually lots of good information for how you might do that. Here's NOAA tides and currents. So you could go to exactly this URL and make a request. And this works really nicely to get information directly. That's how I built that tides thing for my living room. And so this works really well. You can also pay for an API. The paid ones, you get a lot more documentation. They're generally a lot easier to use because you know all the things about them, and you're paying for the service. So there's going to be more documentation to go with it. Not that the NOAA tides and currents wasn't good. It's just not quite as nice as that. So in addition, there's computation. So databases drive the web, right? Everything that you think of as a useful website is driven by a database somewhere. And so at some level, Amazon is computing things all the time. Wikipedia has got tons of information out there. Your bank is going to have info. Twitter and Facebook and all those things, they all have calculations that come from databases. So one of the things, like the information stored on Wikipedia, is served to you by websites or on web pages, and it's pulling that information and adding it to its Wikipedia template. Somebody wrote one template, and then it's going to a database and pulling all the information that would go onto the website. So it's not like someone wrote the web page, they wrote a skeleton, and then it pulls the information and plops it in. Twitter, you can actually recreate fairly easily. It turns out, not like all the fun details of Twitter, but the original 120 characters for a tweet, that's not too hard to set up as an example project. Wikipedia is a little bit more, but it's still not terrible. Like, this is pretty formulaic in how it's laid out, and it works pretty well. But this is essentially what a website's doing, is it's having a database to store all the content, and then you go there. On Amazon, when they add a new item, they don't code a new website for it. They enter all the data that it needs, and then a lot of it is programmatically built when somebody decides that they want to sell anything on Amazon. So algorithms, microservices, and workers. If you want to make the internet work, you can build the internet in modular pieces. Twitter and Facebook do this. Amazon does it. Alphabet is the company that builds Google. And here's Celery, another one that I've used. You can learn all about algorithms. We're going to skip past that. Modular is this is all the rage right now, to have APIs that you build and little pieces of a website. If you're going to build a big complicated service, you won't build it all at once. You're going to have like a database, some service workers, mail server, user authentication, some different things that you might have in order to get that all to work. And then you'll integrate them together in a way so that if you want to fix a part of it, you don't have to take all of it offline. You can fix things one at a time. So modular is definitely the way that people build websites now, and it really helps to make them work nicely. But microservices are when you break all these things up into separate little pieces. Then there's infrastructure, like how do you actually roll this out? These are all services that you can use where you connect the dots between those microservices. And so there's the Amazon way, the Microsoft way, and other ways that you can do it. This gets real complicated real fast. But you know, there's a whole career field that you can go into. Docker and Kubernetes are, if you want to try and break into, correct me if I'm wrong, but if you want to sound smart among developers, you make sure that you're always talking about Docker and Kubernetes.
In some circles.
In some circles.
Otherwise, you'll be complaining about it.
Yeah, yeah, that feels right.
I still need to learn it.
I'm like, I get in principle what they're supposed to do. I'm not good at making them useful for me yet, but I want to get better.
The networking part is the part that I'm still challenged with.
Yeah, it turns out JR is actually really good at these. So if you have a question, you can ask JR. He's pretty good at Docker, not so much Kubernetes, but Docker he's good at. The real world. So if you want to do that, you can also interact with the world through the internet, moving more around than just information. There's Raspberry Pi's GPIO 0. That's how you actually run it like Arduino. P5.js is fun. That's like a graphical JavaScript. You can interact with the world a little bit. MicroPython, where you write Python on small computers that can be internet connected. And the Arduino's like that one, totally. And the ESP32 is a fun device that's in the Arduino space, sort of, that lets you connect to the internet. So there's tons of ways that you can do this. But basically, you can get a server that's connected and have it interact with something in the real world. Like this might be connected to a Raspberry Pi and go get information and display it on a screen that's always on in your living room. Or you could have this where maybe you have like something that's going to Twitter and looking at how angry Twitter is, and it does a little mode for how angry it is all the time. It would always be in the red zone. But you could definitely see all these inputs and output pins to be able to do this. You could do it with Node 0 for Arduino, Python, it's got GPI 0, MicroPython. There's tons of different ways to get control in and out. It feels like it's real intense, but like I've got high schoolers getting their final projects ready, and of the like 8 different groups running projects, 2 of them are internet connected. So it's possible that a high school kid can figure it out. I have full faith that all of you can figure it out better than a high school kid. They're smart kids, don't get me wrong, but I believe that you could do this if you wanted to. So one of the cool things, especially for small devices, is MQTT and the Internet of Things, where you can send small messages back and forth. There's all of these. MQTT is great, and Home Assistant, I should totally add a slide, because there's been a huge proliferation of these like devices that live sort of on the edge of the cloud. You put them in your house, they listen to you talk all the time. They try and sell you stuff that you don't need, all of that. These all exist as the edge of things. And then you can use Home Assistant as a way to try and connect and manage them, which is tons of fun. By the way, if you've never set up one of those, you need a Raspberry Pi and a LAN cable, and that's it. But it'll connect all of these weird things that come from different companies, and you can get them all to play nicely in the sandbox together. So if you've ever struggled with that and smart home devices, that is the way to get those connected. And we can totally work on that too if you want, because it's lots of fun and not that hard to get set up and going. But MQTT is basically like Twitter for robots. It's sending little messages back and forth through a broker. There's no fun GUI. It's like API and Twitter had a baby. That's it. Where you have subscribers, and then when you tweet, or when one machine tweets, the others that are following it, they get it. They call them broker and client, publisher, subscriber, but it's pretty much the same thing as Twitter for robots. And then it turns out you can write apps. There's MIT App Inventor, where you can click and drag and make apps that way. This has got a target age of middle to high school. So it's a fun way to build Android apps if you're interested. So we just did all of the internet. That was a lot happened. I think we should stay, instead of going all the way through this, we should stay focused on our first round, which is this.
Is that second set of slides available via
It's all,
Slack or?
yes, all of it's there. So you can get to all of it. If you want to dig through and read all the details,
Yeah.
you can totally do that. And I'm happy to talk with you anytime about how this works because these are all things that I have used or loaded or tried to use at different points. And so there's lots of fun to be had in trying to figure these out. But our big goal for the week is to try and SSH and to use your computer to access the small computer in the room and to see what's going on. Oh boy, there was something in the chat. I'm worried I missed a question from a long time ago. Oh yeah, AOL dial-up. Yeah, that one feels like a long time ago. But I totally got yelled at as a kid about you're on the internet too long. Stop. There's nothing even good on the internet now. Why?
Phone and it's just, or you pick the phone up and it's just screeching.
They just
squealing,
screaming at you. Yeah, I'm so glad we're past that part of the internet here. Although there's still like, what amazes me is that there's huge parts of America where you can't get access to high-speed internet.
Yeah.
And then, but like some parts of Europe have made access to high-speed internet a fundamental human right.
Right.
Which is kind of wild. Like there's all sorts of interesting things to think about the internet. But it's time for the better part of class, which is show and tell. And so what we should do is, let's see, we have people who are remote. If anybody wants to go there, or we have two people in the room, we can go either way. If anybody turns on your camera fast, we'll know that you want to share, but otherwise we'll have the people in the room go for it.
I can go.
Yeah. All right, let me cut over to view you. We've got this camera that I can put a little closer, maybe.
We can just continue to sit here probably.
Yeah, just sit right there.
So I am pretty fascinated by the whole composite material thing. And I use some of the stock of carbon fiber that's somewhere, probably in the back, right? And made this carbon fiber mold of a bowl. It's very much stuck to the mold right now, so we're going to try and fight that off after class. But I think it's super cool. And I've done like some fiberglass stuff with boats when I was younger, and it's pretty similar. But it kind of is like, you know, what else can you make out of carbon fiber? Bicycle parts or motorcycle parts or car parts or anything really. Pretty awesome, honestly. Like, oh yeah, really isn't that hard. So yeah, it's a cool thing. It was cool to play with it and kind of like think about where it could go.
And I really like how the mold, like there's a good side and a bad side to the mold.
Yeah.
Right. Like here's the you can see the bad side of this mold, right? And there's the good side. It's so good that like there's the plastic mark on the bottom of the mold bowl that it came from. So like it's wild how much detail you can get with all of this.
So I was watching a guy on YouTube who was took basically like a panel off of his car and covered that in mold release, and then put fiberglass over that, and then used that piece of fiberglass as a mold for carbon fiber.
Oh,
so he made a mold out of he used the piece to make a mold, and then used the mold to make the piece out of carbon, and then to put it onto his car. And it came out pretty awesome. And he didn't even vacuum form it. He just did a wet layup and let it harden. And it was like, really wasn't even that much stuff that he had to have.
Yeah.
Like it was pretty cool. So
it's really amazing how like the bag layup is good to do as if it's a group experience. Sure. But you can totally get away with a wet layup a lot of the time.
Yeah.
So
especially for like a non-load bearing, like,
yeah. If it
just is deflecting air.
Yeah, that's all it's doing. So like for something like that, it's super nice to be able to just like do the layup and that's it.
Yeah, it's something that was never in my in the realm of things that I would consider like, I'm gonna make my own carbon fiber parts, but now it's like, I'm gonna make my own carbon fiber parts. Why wouldn't I?
Yeah, it's totally possible.
Totally weird.
I really loved those gloves. So you had gloves that you brought in yesterday?
Yeah, I have my motorcycle gloves have carbon fiber armor on them, armor essentially, right? And they weigh pretty much nothing and they're super strong.
Yeah. Yeah, it's really I want to know how they stitched it into the glove.
I don't know.
But like they did somehow, and it's
Yeah.
just sewn into the material. It was really cool.
Yeah.
Yeah, awesome.
So yeah, that's what I've been up to.
Thanks. Let's see, Lisa, your camera is on and you're unmuted. Do you want to share what you've been up to?
Well, you know what I've been up to, and I'm finally done. And I don't know if there's going to be a way to show. Can you see the difference between these two bottles in
Ooh,
terms of what
yeah.
you're seeing in there? So that was what I made my call today about. This one was a much bigger batch than this. This is the final one. And so you see this kind of white area on the bottom right
Yeah.
here, from here to here. I was really upset to see that happen because I used a really heavy duty filter to make sure that wouldn't happen. And I found out what I did wrong. And that is that when you boil this to the temperature that it
Let's
needs,
make syrup. Sorry, yeah.
yeah, when you boil it to the temperature you need to in order for it to become syrup, it also, you want it to be hot when you jar it, right? So it will be safe. Well, what I did was I filtered it and I poured it back in the pot and I heated it up to it's starting to boil again, and that was wrong. If it starts to boil, then syrup forms, like there's minerals that come out of the tree, and
Yeah.
it forms something called sand. And
Oh,
every time you boil it, somehow it pulls more minerals out of there that form more sand. And so that's what happened. It's perfectly good. It's beautifully edible, but it's just not as pretty. And this one, I realized after I spoke to them, just don't make it boil. And so it's crystal clear.
oh, that's awesome.
Yeah,
So you could like heat it up to almost a boil,
right,
but make sure that it didn't like cross that barrier.
exactly. So I made it go to actually 200 degrees. I figured that was good enough because when it started, when I saw the first bubble, that's just already too much.
Yeah. Yeah, that's fascinating.
Yeah.
And how many years have you made maple syrup?
3.
3? That's
And
pretty
this-
exciting.
This is the first year I actually tapped 4 trees. The idea thing is like I try in the warm months to identify which trees are maple, but then I totally forget.
Oh,
The
yeah.
thing is the leaves are up so high, I really can't tell. So I just basically look at the bark and decide and take a chance. I learned that you can practically tap any tree and there'd be a use for what comes out. It all depends. Like, for instance, you could even tap a pine tree. And of course, what you're going to end up making is tar. But
Yeah.
I got it right. Every tree I tapped was truly a maple tree. And
That's awesome.
doesn't have to be a sugar maple.
Oh, that's interesting. And I wonder, like, you know, what happens if you tap a sassafras tree, you know, like different,
Yeah. Huh.
different types of tree. You can get different sorts of stuff. Yeah. I'm curious. I'm going to go down a rabbit hole.
Birch syrup.
There's birch syrup.
Yep.
Yeah, my son tapped birch trees like 2 years ago or last year during COVID. And he's really, really good at this. And he made a lot of birch syrup, and it takes way, way, way more sap to boil down to get to syrup on a birch tree than it does maple.
Huh.
And what you end up with is a product that tastes more like molasses, but a very like delicate one. It's really good, but you wouldn't want to put it on pancakes.
Okay. All right. Fair enough. Pancakes are a life priority. So I'm just going to base things around
Yeah.
a pancake decision. So
Yeah.
that's good to know.
So
Awesome.
and I'm really just wanting to get in and see the bowl, but the question is, how will I get the bowl off of the fabric?
That is a good question. So like you just tear it is basically it. Like it's wrapped in plastic right now.
Yeah.
And when you rip all the plastic off, and it's pretty aggressive. Like that's a pretty, because of the vacuum pressure, you get like little kinks and crinkles that hold the plastic on pretty tightly. Like I've got one here that's overhung. And we're going to talk about molds and molding and casting, so you'll understand a little bit more why that happens.
Yeah.
I had to pull pretty hard on mine.
Yeah. Oh yeah.
I had to pull like pretty hard.
Like I went to the scroll saw and cut off parts to make it easier to pull. Like you might have to be pretty aggressive, and don't feel bad. Although I think, Lisa, though, I was speaking your praises when we did it on Sunday, because yours never went around the bowl. Like mine wrapped over the plastic, and that was a problem.
Okay.
Yours does not do that at all, and so you should have a much easier time popping it off.
Okay.
Because I think it's going to be much easier for you.
I was kind of hoping you popped it off already because I really wanted to see it. But that's
I mean, I could totally do it and send you a photo, but it feels like opening a Christmas present or a
I agree.
yeah. So I think that you'll like doing it when it's time.
I'm taking the tessellations class tomorrow.
Ooh.
Do you know about it?
No, I don't know anything about it, but it sounds like a delight.
At MakeHaven, they're offering it's like almost an origami thing on paper where you fold it a million times and then.
Oh, yes, I know that class exists. I don't know. Maybe I'll come like sit nearby. I am not enrolled in it, but I'm really curious also. I think it's somebody who's very good at folding paper.
Yeah.
That ought to be fun. That ought to be really fun.
Yeah, so I'll be there for that. So that's I think I'll come in before then to deal with it all with all the other stuff. I wish that you would program the Raspberry Pi so that in addition to a blinking light, it would also have a sound.
Yeah, that would be. It makes the hide and seek way easier though.
Yeah.
So it'll just blink. Plus, like we're sort of dancing on an edge here. It does feel ominous to have a little weird electrical box start blinking in a space.
It's like duct tape to a black box.
It's going to be taped to a weird, basically like we're trying to make sure that it does not look like an ominous device. And so just blinking is enough. Blinking and beeping, it can really go south.
I guess.
Yeah, so it's fun, but everybody should have a good time for the hide and seek. Norm, you've also got a camera on.
Yeah, well, it was just a comment on your saying that it's like opening Christmas presents, because that would be true if Christmas presents came from hell. But I've just had the worst time. I had to use metal shears to take it out at all. And then when I tried to peel it off, as you said, I was utterly defeated. I thought about using a scroll saw. I wasn't sure whether that would be bad for the blades or something, because honestly, it feels like metal or something. I'm not sure I'm ever going to get that off, but that'll be my project for this week. I think trying to de-plasticize that piece of fabric.
Oh, I agree. It can be very aggressive. Like there's definitely ones from last year that never got removed from their bowls. So don't feel bad. With the plastic bowl also, you should be able to pass the composite and the bowl through the scroll saw. So you could separate it that way, like cut it along the edges.
Yeah, I might do that. That sounds workable. And it would be the scroll saw, not the bandsaw, right?
Yeah, the little tiny scroll saw is the way to go.
Okay.
So just take your time, go nice and slow. The blade that's on there right now is a like every direction blade, so you can push it through however you want. And it works nicely.
I'll do that.
Awesome. Yeah. Let's see. We've also got Arvia and Vincent. If you guys want to share what you've been up to.
I can go.
Arvia just unmuted.
Oh, sorry. I've changed my phone. Hey, how do I don't know. Some reason it's on portrait mode on my phone.
That's all right.
As everyone else, I did the bowl, and Norm, fill you on trying to get out. Corey had to like, it was like a 2-person job, and we had to use the clippers and all that. But this is my bowl so far. Oh gosh. Okay. This portrait really doesn't want me to be great. Let me flip my camera around. Okay. So this is my bowl so far. If I could get it to focus on the actual bowl, y'all, sorry. We use the muslin, and I cut out pieces of wood veneer to put in it. I think next time, well, one, I'm gonna go in, I'm gonna put another layer of epoxy on it because it's really thin. So like, yeah, it moves. I put 2 layers of the muslin, but that definitely was not enough. But I do want to try it again because I think I want to put like gold leafing in it too. I feel like that would be really cool with the muslin. And yeah, I'm gonna cut the edges down so that they're smooth. Trying to get some light because my house is really dark. What else? Yeah, that's it. I wish the outside looks like the inside. The inside is very smooth and very nice looking, but then the outside is glossy and not as pretty. But yeah, I like it for a first
Yeah,
try.
I think that you should be able to sand the outside of that, and you ought to get some of the like ridges down, and then, but I would only do that if you're going to do another layer of epoxy on top, right? Because
Yeah.
it's gonna get dull, and then the epoxy will bring the shine back to it. So it might cut the ridges down. It also could end up looking weird, but it, you know, if you've got ridges that are really high up, sanding them
Mhm.
off or like hitting them with a file actually could bring them down pretty substantially.
Okay, yeah, I'll try that, or I might just try another bowl and use, layer up more muslin and veneer. Yeah, I was
Yeah.
thinking about like on the veneer putting not just gold flakes, but like the liquid gold stuff. I can't even think of what it's called, y'all. I'm so tired. But like doing a design on the triangles or whatever shape it is so that like the gold reflects through the muslin.
Oh,
If that makes
cool.
sense. Yeah, but yeah. So I like
And
this. This is really cool.
it's fun. And you could do a wet layup too. Like you really don't need the vacuum bag for a lot of cool projects. So
Mm,
there's tons of options for how you might do it. But it's totally a play around, futz around with it so you get what you want. And then you'll be a master of how to do that process.
cool. Can I put sorry, turn back to myself. Can I put the gold flakes and then the epoxy on like the wet layup of this?
Oh yeah, totally. Like the
Okay.
gold, you know, if you've just got like the flakes of gold, like you might have in a like gold leaf you can get sold, or like I'm imagining the college days with Goldschlager, like
Yeah,
the little gold flecks, that
I have
stuff.
some the flakes.
Yeah, the little flakes,
Mhm.
those little flakes would look cool, sort of speckled in through it.
Okay, yeah, I'll try that and I'll update y'all. Tell you how it
Awesome.
went. Cool.
Sounds fun.
Yeah.
All right, and then we've got Vincent in the room, and let's do a quick cut over to Vincent. Vincent, what have you been up to?
So I'm still moving, but I made a few things that would help out with the move. Getting some practice with the Shapoko. Maybe not as smooth as I thought it was going to turn out, but we're going to figure this out. I made this hole boring jig so I could drill a bunch of holes on my desk because I need 2 separate monitor stands, and they just don't look right when I try to put them next to each other. Like they don't touch. I'm trying to make one vertical and one horizontal, and there's like a giant gap in between. So I'm just gonna drill a ton of holes and just put the monitor wherever it looks best. I use this, I still need to drill all the way through. When I get some free time, I'll troubleshoot that. I probably should have done this yesterday before I started routing, but I have a dust collecting port to put on the router. So I can now put the vacuum cleaner attached directly to the router.
Nice little 3D printed attachment.
Is that for the Shapoko or for the router that you're using at your house?
The one at my house.
Okay, cool. Nice.
But they do have a bunch on Thingiverse that
Yeah,
you can customize, choose the sizing and whatnot.
cool.
I have some other attachments that are on the print bed right now.
That's great.
Vincent, what are you using? Sorry, I don't know how to jump in here. Well, Vincent, what are you using the router for at home?
So I can make a giant row of holes.
Oh, so it's for this. Okay, yes. Okay.
I made this on the Shapoko, and I was going to use this with guide bushings so I could just follow the shape of these holes at the
Okay.
space.
And the guide bushings would let it be perfectly centered, or would they be so you have a tighter circle inside? Basically.
Yeah, so that way I wouldn't I wouldn't risk cutting it using, say, a pattern bit,
Sure,
which I haven't used before, so I wasn't sure if I could plunge with them.
not really easily. Like you can, if it depends, there's a bunch of details to that. But a guide bushing is gonna be great, so.
I figured the guide bushing, there's like no chance of me like ruining the template or anything like that, as long as I have this set up.
Right, no, I'm totally with you. The one thing that I would be careful, a guide bushing is like a fixed piece you put in a router that sits out from the bit a little bit. I would just worry if your thought was to slide that down perfectly into the holes that you have there. Like that is probably not a good plan, but using the guide bushing to roll around on the inside, so you're making a little tiny spiral, gonna work perfect.
Yeah.
Yeah, okay. Just, worth saying out loud.
Yeah, it was supposed to be like a 3/4 inch hole, and then I was gonna use like a 5/8 inch guide bushing with a 1/8 or 1/4 inch bit.
Yeah, so you could do a little spiral and make the hole you want. That makes sense. That's good to do. Seems like it should work. We just need to get the Shipoko to spit out the right holes for you. Awesome. All right, so people have been doing lots of things, it sounds like. That's been lots of fun. For me, what I have been up to this week has been helping all of you. And then also, I feel like I've almost finished that piece of furniture. So the next time that you come in, you should take a look at the red Made at MakeHaven logo, where we were adding our spare epoxy onto that piece of furniture. I've sanded it down, so now it's totally flat. It could probably use a clear coat on top just to bring it into being transparent again. Because right now it's a little, I would say it's translucent. I sanded it with 600 grit sandpaper. I should probably use a car polish to get it clear. And then like a polyurethane over the wood to bring that back into being secured by something. So that's what I've been up to. And when you come in, you should see it. I've also been recording lots of different parts of that, and I hope to, over the next week or two, put together a video of like how that went from idea to thing. And it's the example that I'm going to reference all the time during our Make Something Big CNC week that's coming up in a little bit. So we've got a couple interesting weeks. Next week is going to be a wild card week or an integration week where you're integrating ideas into something. It could be any of the ideas that we talked about so far or other ones that you've got. And then it'll be fun to do show and tell for that. And then we're going to have if I'm not mistaken, I should double check, but I think it's a break week after that because it might be my spring break. So we've got a few interesting things coming up on the slate, but thinking about an integration project over the next 2 weeks makes a lot of sense. Then we can connect at some point and get you tied into the server. So that is the plan. It's fun to see all the bowls come out of their plastic boxes. And that's it, everybody. So we'll say good night and see you all soon in the space.